Hey guys, so today I'm going to be walking you through material from Chapter 2 for your Math 200 class. We're going to be toggling between StatCrunch and PowerPoint, so I'm just going to leave this kind of small here as I go through some of these things. I already have a bunch of data loaded into StatCrunch, as you can see, but I'm just going to walk you guys through kind of some of the content for this and then how to actually go about creating some of the graphs that we're going to create for this chapter. So chapter 2 is all about organizing and summarizing your data. So we're going to start with section 2.1, which talks about organizing qualitative data. Now you guys learned about qualitative data from chapter 1, so we're going to talk a little differently about quantitative and qualitative data. So let's start with qualitative data. One kind of thing to talk about is that when we collect data from some kind of survey or designed experiment, a lot of times we need to organize it somehow. So data that's not organized is referred to as raw data, and that's just what you collect from your survey or your experiment. There are a lot of possible ways to organize your data. You can use tables, graphs, and then one kind of major thing that we typically always do is coming up with some kind of numerical summaries, like mean, median, mode, that sort of thing. And we're going to be talking about that in chapter 3. But today we're going to kind of focus on the first two things, which are tables and graphs. So I first want to talk about what a frequency distribution is, and then I'll walk you guys through an example in StatCrunch. So a frequency distribution, I'm sure you've seen this before, even if you didn't know the name for it, basically just lists all of the categories of your data and the number of occurrences that are associated with each category. And then a relative frequency basically is the exact same thing, but instead of giving an actual number of an occurrence, it gives you the proportion of observations within a category. So in order to find a relative frequency, all you do is you take the frequency for that category and you divide by the total number of frequencies. Now, a relative frequency distribution just lists each of the categories along with their relative frequency. So we're going to look at this data for M&Ms, and we just have the colors of M&Ms in a bag of plain M&Ms, and we want to construct a frequency distribution and a relative frequency distribution for the color of the plain M&Ms. So this is how the data originally looks, okay? And this is how we want it to look. So I'm going to show you guys how to get this. Now, what you'll notice down here is that I have little StatCrunch instructions. These are very brief, but this will hopefully point you in the right direction if you're a little stuck on this. So when you see this, you could create the frequency distribution and the relative frequency distribution by hand by just counting how many times you see the word brown, yellow, red. But there's absolutely no point in you wasting your time doing that because we have technology that will do it for you. So I'm going to pop over to StatCrunch here for just a minute. You can access StatCrunch directly through your homework. In that same kind of area where you see the Ask My Instructor button, you're going to see a StatCrunch button. And when you click on that, you're able to kind of access the same kind of screen that I have here. If you access the data directly from your homework, you can open it right in StatCrunch. You won't even have to paste the data in, it will already be there. And that can be done by just going to the data table that's displayed. There's normally a little rectangle kind of on the top right of the data table. And then if you click on that and you go open in StatCrunch, it'll open it up right for you. Or you can just open StatCrunch via your homework on that link on the right-hand side where it says StatCrunch, and then you can paste the data in there. So we're going to look at the M&M color. This is this first column that I have right here. I have a bunch of data in here because we're going to do several different examples. But we want a frequency table, and we want relative frequency displayed as well. So if you look down here at my instructions, it just says stat tables frequency. So that's exactly what we're going to do in here. So I'm going to click on stat, tables, and frequency right there. We're talking about M&M color, so I'm just going to highlight that column right here. And if you look down here, I don't need a where statement because I just want to include all of the data. I don't need it grouped by anything in particular. It's just going to group it by color because StatCrunch is going to kind of know exactly what we want to do with it. I want frequency and relative frequency. Those were already highlighted, so I didn't need to go in and do that. But if you wanted something else here, you could also select other options. And then I'm just going to do compute. And if you look at what we have right here, it gives you the M&M color, blue, brown, green, orange, red, and yellow. It gives you the frequencies and the relative frequencies, which is exactly what we have right here. Now, moving on, I'm sure you've all seen a bar graph before. That's just constructed by labeling each category of data along the horizontal or the vertical axis, and then you have the frequency or the relative frequency on the other axis. Rectangles are then drawn. They should all be of equal width for each of the categories, and then the height of the rectangle just represents the frequency or the relative frequency. Now, something you might not have heard of before is a Pareto chart, and that's just a particular type of bar graph where the bars are actually drawn in descending order of frequency or relative frequency. So we're going to look at the same M&M data, and we're going to go ahead and construct a frequency bar graph, a relative frequency bar graph, and then a Pareto chart. So this is what our just normal bar graph is going to look like. So I'm going to go ahead and close out of my frequency table, and I'm going to go to graph, bar plot, and then with data because I have the actual raw data in my M&M color column. If I already had summarized data where it had the number where I have brown, the number yellow, the number of red, then I would do with summary instead of with data. But I'm going to do with data. I'm going to select my M&M color, and if you take a look here, for the first one I just want frequency, so I'm going to leave that there, and I don't want any particular order, so it's just going to put it in ascending order based on value, which I think is the name of the color. So this is what this one looks like. Looks pretty much like what this does right here. The only thing I'm missing is a chart, or a chart title. So if you go to Options, Edit, that's going to allow you to change this if you just have a small thing to change, and you can go ahead and put a title in here if you want, just like I did with this one. Now, if I want a relative frequency instead, which if you look along the y-axis, it has proportion instead of frequencies, I'm going to do Option Edit, and then instead of frequency, you can just select relative frequency, and that's going to change this. You can drag this to make it a little wider, and again, I could add a title if I wanted. It has M&M color along the bottom labeled there, and then relative frequency in this direction. Now if I want a Pareto chart, the only thing that I'm going to change, I'm going to go back to a frequency. Okay, so I'm going to do Options, Edit, get it back to frequency. But then if you take a look here, instead of not selecting a particular thing for order by, this time I want to order by count descending. So if I go here and select count descending and do compute, it just reorders the categories at the bottom so that I have the largest category first and the smallest category last. So I have 12 brown M&Ms and only 3 blue M&Ms. The other thing you'll notice about StatCrunch, if you kind of hover over these things, it gives you the frequency and tells you exactly what number that is, so you don't have to do any guessing. Now, I know you've all seen a pie chart before. StatCrunch will also do this for us. Okay, so a pie chart is just a circle that's divided into sectors, and each sector represents a category of the data. And it's going to be proportional to the frequency of that category. So if we take a look at this data right here, we have marital statuses for 2006, has different frequencies, everything's in millions. So for example, in 2006, we had 55.3 million US residents 18 or older who had never been married. Okay, and we just want to draw a pie chart. It's going to end up looking something like this. We can customize it a little, we can change the colors, but if we want to do this in StatCrunch, all you have to do is go to Graph, Pie Chart, and with Summary. So let me close out of this one. I have my marital status data over here along with the frequencies. So I'm going to do Graph, Pie Chart, and I'm given summarized data this time instead, okay, because I have the categories and then the frequencies within those categories. So my categories are my marital statuses, and my counts are in the frequency column, I believe. Yeah, I titled that frequency. You always want to put titles here so it's easier to figure out what you're selecting. And I'm good with the basic 7 colors. There are some other things you can select there, but this is good enough. We could add a title if we wanted. If I do compute, it shows me this right here. It's going to display the number. This is again in millions based on the raw data that was given. And then it also displays the percentage here. And you can customize that a little bit to kind of fit your needs. But that's how you create a pie graph or pie chart in StatCrunch. Now section 2.2, A lot of the same stuff, except now we're going to be organizing quantitative data, so we have a couple of kind of additional ways that we can do this. So the first step for summarizing quantitative data is to determine whether the data are discrete or continuous, and we learned about that last time. So discrete just means countable, like has values of 0, 1, 2, 3, 4, and so on. Continuous means that our data can take on values like 1.5 or 2.5 or something like that. If the data is discrete and there aren't very many categories, then really we can kind of treat it the same way that we did our qualitative data. Now, if our data is discrete, but there are a lot of different values for our variables, or if the data is continuous, then we have to actually create classes or categories for our data. So if we take a look at this example here, we have, it looks like a survey of 50 households was done, and all they did is they recorded the number of available cars in a household based on this random sample. And we want to construct a frequency and a relative frequency distribution of this data. So this is our raw data here. And if you look at what a relative frequency distribution looks like, it looks something like this. All it's done is it's taken our raw data and it's just allowed us to kind of put it in a form that we can sort of read it. Okay, so it's a little more organized, a little nicer. We can see very easily that the largest category is the number of households that have 2 cars. So in order to do this, it's the exact same way that we did our M&M color frequency and relative frequency. So that's just going to stat tables frequency. So stat tables frequency, I want the number of cars data, and I want frequency and relative frequency, which hopefully you can tell these are kind of shaded a darker gray. That means they're already highlighted. And if you do compute, it gives you the values here, 0, 1, 2, 3, 4, and 5. Now, since we don't have very many levels of this, meaning I don't have households that have 100 cars, it's pretty easy to display all of the possible values here. So this is treated exactly the same way that our qualitative data was with the M&M colors. Now, a histogram can be created in StatCrunch. I'm not going to show you guys how to do it, but you can create a histogram by going to Graph and then Histogram. And that's just constructed by drawing rectangles for each class of data. The heights represent the frequency or the relative frequency, depending on which type of histogram you're creating. And the width of the rectangles is going to be the same. And then since we're talking about data that's oftentimes continuous, our rectangles can actually touch one another with a histogram, which is the main difference between a histogram and a bar chart. Now, I talked a little bit about classes a couple of slides ago, but I want to talk about that in a little more depth. Classes are just the categories that data are actually grouped into. So if a data set consists of a large number of different discrete data values, or it consists of continuous data, we want to actually create classes by using intervals of numbers. So if we look at this example here, what we have is we have data on people who are aged 25 to 64 who are currently work disabled. And all of these numbers are in thousands, okay, so the actual values are more like in the millions. But if we take a look here, for people aged 25 to 34, we have 2,132,000 people who are actually currently work disabled, and I'm not sure what year this is from. But if you look at this data, we have a lot of different data points, right? If we look at every different age group that we're talking about, we have 25-year-olds, 26-year-olds, 27-year-olds, 28-year-olds. And if you can imagine kind of listing all of that out, we would have a lot of different data points and a lot of tiny numbers. And it would be really quite difficult to look at. So what they've done here is they've grouped our data into classes that are kind of logical and hopefully make sense. They have basically just collapsed the age groups so that we have ages 25 to 34, and then 35 to 44, and so on. So if we take a look at kind of some of the terminology, the lower class limit is just the smallest value within a particular class. The upper class limit is just the largest value within that same class. So if we look at the first class, this 25 to 34, 25 is our lower limit and 34 is our upper limit. If we look at the second class, our lower limit's 35, our upper limit's 44. Another term that you're going to probably come across is class width. All you have to do to find the class width is look at the consecutive lower limits. So from 25 to 35, if you subtract those two values, you get a value of 10. So that is your class width. 35 to 45, if you subtract those, 10 again, and 10 again. We would like our classes to all be the same width so that we're kind of comparing equal ranges. So there are some kind of rules about creating classes. It's more of an art than a science, okay? But the choices of the lower class limit of the first class and the class width are pretty arbitrary. Now, you want to pick something that makes sense, okay? And there isn't really a way that I can tell you that's always going to come up with the perfect classes, okay? But as you kind of practice this, you'll get used to creating nice classes, and you won't have to deal with it too much in this class because normally in my math lab for your homework and on quizzes or tests, I would sort of have it already grouped for you, okay? Or it should be fairly obvious, a nice way to group it. But there isn't one correct frequency distribution for a particular set of data, but some might be better than others, okay? So you just kind of have to practice with it. You want to use the distribution that provides kind of the best overall summary of the data. So for example, if we had values like this, we probably wouldn't want to start a group at age 26 just because it's not as nice of a number. So perhaps we chose 25 just because it was a 5, a 10, something like that. So you kind of want to start your lower class limits probably at sort of nice numbers, and you would like your class width to maybe be something that's kind of an even number like 5 or 10 or 20, something like that. It completely depends on your data, okay? So the rules that I just told you don't even always apply, but if you're just getting used to it, just starting with this, that's kind of a good thing to go by. Now, stem and leaf plots, I'm sure you've also seen before. They basically use the digits to the left of the rightmost digit to form the stem, and then the rightmost digit is called the leaf. So for example, if you have a data value of 147, all you do is you look at the rightmost digit, which is a 7, that's going to be your leaf. Everything to the left of that is your stem. So the stem is 14 and the leaf is going to be 7 for that kind of value. So let's take a look at this data here. We have unemployment rates for a bunch of different states. I think it actually has all states on here. I'm not sure what year this is from, but it has the unemployment rates. So for example, in Indiana, 5.8%. So we're going to let the stem represent the integer part of the number, and the leaf is going to be the decimal portion. So for example, if we look at Alabama, which was 4.7%, 4 is going to be the stem, and the leaf is going to be 7. So if we take a look at this, one other thing, split stems. So when you have data that's pretty bunched together, you can actually create something called a split stem and leaf plot, and I'll show you what that is in just a second. But as with the determination of class intervals, deciding whether or not you should use a split stem kind of is a judgment call. There's no such thing as a correct one or an incorrect one, but some are just better than others. Now, thankfully, StatCrunch actually helps you with both of these situations where you're doing class intervals and split stems. When you put your data in, it kind of automatically figures out what you probably would like to display, and then if you want to customize it, you can do that. So in StatCrunch, let me show you how to do this. All you do is graph and then stem and leaf. I have the unemployment data already in here. So if I go to graph, stem and leaf, I'm going to select my unemployment rate data. And I'm not going to select a leaf unit. I'm going to let StatCrunch decide for me what I want to do with that. And I'm given something like this. Okay, so you'll see that the lowest unemployment rate that I have is 2.8. The highest that I have is 8.5. And then what you'll notice is that we have 2 different values for 3, 2 different values for 4, 5, 6, and 7, and 8. The reason for this is because this is a split stem. So instead of grouping all of the 4s in one line, what they've done is they have 4.0 to 4.4 on the first line for the 4s, and then they have 4.5 to 4.9 on the second line. And that just allows you to split your data so that it doesn't look all bunched together when you actually look at it. So this just allows you to see your data a little more clearly. And again, StatCrunch is going to kind of help you make that determination, and it's going to go ahead and create this for you if it seems like it is a good fit for your data. Now, one advantage of stem and leaf diagrams over histograms is that the raw data is kind of still available to you when you're looking at the stem and leaf plot. So for example, I can look at this data right here and I can reconstruct all of the unemployment rates for the states. Now I don't know what they belong to, but I know that one of the states had a 2.8 and another state had an 8.5, for example. So that is kind of nice. When you look at a histogram, the raw data is pretty much lost unless it's reported with a frequency distribution. But that is one nice thing about a stem and leaf plot. You still have your raw data in front of you. Now, a dot plot is another type of graphic that we can look at. It's just drawn by placing observations kind of horizontally in increasing order and placing a dot above the observation each time it's observed. So if we take a look at that number of cars data that we had for our 50 households again, all we have to do is go to graph dot plot. So let me close out of this one. I'm going to go to graph dot plot. I'm going to use my number of cars data. I could pick kind of some different things here. I could add a title, but really I just want to show you this is what it ends up looking like. So we have one dot for each of the households, so we have a total of 50 dots on here if we actually look at them. And if I mouse over this, it's going to give me some information here. It's showing me what row my data is actually from. Okay, but it looks like we have 4 households that had 0 cars, and we could count the rest of these to kind of see only one household with 5 cars. So it shows us the same thing that a frequency table would, but it's kind of in a more visual form. All right, now I want to talk about just some of the kinds of distributions that we're going to see. Okay, so that pretty much wraps up the StatCrunch portion of this tutorial. Really, the two things that I want you to keep in mind is that if you want to create some kind of graph, chances are you're going to be going to this graph tab. Everything is normally in a sort of logical spot, but you're going to be pretty much using the bar plot, the pie chart, histogram, stem and leaf, and box plot for this chapter. And then the other place that you might need to go is into stat tables and then a frequency table if you want a frequency or a relative frequency. So those are pretty much the two areas of StatCrunch that you'll be using for this chapter. All right, now to talk about the couple of different kinds of distributions you're going to see in this particular chapter. So this just sort of introduces you to what a distribution might look like, okay? So first we have a uniform distribution, and that just is something where the frequency of each value of the variable is evenly spread out across the values, okay? And we'll look at that in just a minute in a sort of visual sense, okay? A bell-shaped distribution is where you have the highest frequency in the middle, and then the frequencies kind of tail off to the left and tail off to the right of the middle. But it's pretty symmetric, okay? And then you have things where you have a skewed right distribution and a skewed left distribution, okay? And I want to look at the pictures for those to kind of show you what those actually look like. This first one right here is a uniform distribution. It's symmetric because if you think about kind of cutting this in half, it looks the same on the left as it does on the right, but it's flat all the way across. So that's something that's uniform. This one right here is bell-shaped. We're going to be talking about the bell-shaped or normal distribution quite a bit in this class. It sort of just follows a nice little bell. It is also pretty symmetric because if we cut it in half here, the left-hand side and the right-hand side look pretty much the same. Now, in terms of skewed right and skewed left, these are two that students tend to get a little mixed up, okay? So all I want you to keep in mind is I want you to ask yourself where the tail is, okay? And by tail, I mean kind of that trailing part of your distribution. So if you look at this one right here, you can see that it has a tail on the right. That means that our data is skewed right. This one right here, the tail is on the left, so it's skewed left. So all you have to remember is that the name for the skew just goes with the tail. So if you have a tail on the right, it's skewed right. If you have a tail on the left, it's skewed left. All right, last section for today is section 2.3, which talks about graphical misrepresentations of data. So this is kind of a fun little quote here. Statistics, the only science that enables different experts using the same figures to draw different conclusions. And this is one really important thing that I want you to get out of this class, is that statistics can be used in a lot of great ways, and it can also be used to kind of manipulate, okay? And as part of your quiz, you're actually going to find an example of where statistics maybe has been misused, okay? Somewhere where a graphic has sort of misrepresented the data. So if you want to construct good graphics, there are a lot of different kind of rules you can go by, but we're just going to go by a couple of them here. So you want to make sure that you have a title on your graphic and that you've labeled the axes really clearly. If you're talking about numbers and they're in billions, you want to make sure that you've put that on the actual axis. So include units of measurement, data sources. Avoid distortion, so never lie about where the data is coming from or just make up data completely. You always want to try to kind of minimize the amount of white space that's on the graph. Use the available space to let the data stand out. If your scales are truncated, you want to make sure that you indicate that really clearly to the person who's reading that. And you also want to try to avoid clutter. So you probably don't want like a picture behind your bar graph that's going to kind of distract from it. You don't want a bunch of grid lines, unnecessary backgrounds. You're not trying to distract the reader. You want to kind of show the reader what the data looks like, but not actually distract them from it. And then avoid three dimensions. So three-dimensional graphs, they might have their place, but they can be really distracting. And oftentimes, depending on how it's oriented, the particularly 3D pie charts can look very kind of misleading because that part of the pie that's going to be in front is always going to sort of look the largest. So oftentimes it can lead to misinterpretations. So just be careful with 3 dimensions in particular. And then try not to use more than one design in the same graphic. Sometimes graphs use different designs in one portion to draw specific attention to that area. You don't ever want to try to force the reader into kind of making a specific conclusion. You want to let the data speak for themselves. And then you want to sort of avoid relatives graphs that don't have any data or scales. So things where you just have pictures that are kind of representing something that's really difficult for someone to look at and make solid conclusions from. I would make sure that you look through your textbook for section 2.3 because they go through a lot of examples where data has been misrepresented, and they kind of show you how you might go about fixing that. So I'd make sure that you read through the whole chapter, but in particular take a look at some of the graphs for section 2.3 and the ways in which they kind of suggested fixing the graphs. So that is pretty much it for this week. The lecture is pretty short because chapter 2 is not very heavy on computations. You just have to kind of play around with StatCrunch, get used to it, learn how to create some graphics. You're welcome to use Excel to create a lot of these graphics as well. Some of them are easier in Excel, some of them are harder in Excel. It just kind of depends on what you're trying to create. You can use either. Your textbook also includes instructions for Excel, so you're welcome to use that as well. But please let me know if you have any questions, and that is it for Chapter 2.